Hello. For our second example of writing a linear model, we're going to look at life expectancy. We are told in the first bullet point that life expectancy has been following a linear model since the year 2000, and we're to create a linear model for the life expectancy of males based on the time in years since the year 2000. So when I go up here to the top of my screen, I have data, and I want to take a look at that data and what it tells me. So the first thing I notice is that in the year 2000, life expectancy was 74.3 years, and for people born in 2010, it was males for 76.2 years. So what I need to figure out is the rate of change, because I've been given data points, but I have not been given the slope. This 2000 is actually going to be my start, that the life expectancy starts there at 74.3 years. And so I know in my y equals mx plus b model that that is b. But I have to figure out m, the rate of change. So the first thing I'm going to do is figure out the change in life expectancy. So life expectancy goes to 76.2 years, and it started at 74.3 years. So when I do that subtraction, I end up with 1.9. So over this time period, life expectancy increased by 1.9 years. But it did not do that just instantaneously. It did that over a certain time frame. And so I also have to figure out the time frame. Now the time frame is really easy. I can do it in my head, but I am going to write it out so that you see it. In 2010 is where we got this number of 76.2, and we had started back in the year 2000. We do that subtraction, and we end up with that happened over 10 years. And so I do that division, and I get 0.19, and that is how much life expectancy is changing per year or each year. So it is increasing by 0.19 of a year each year. Now, when I'm doing this, I'm actually using a slope formula. So I'm going to work back this way. So we use the letter m for slope. And we know that m is the change in y divided by the change in x, or we might know that as the rise over the run. And we have often memorized a formula for this where we take y2 minus y1 and divide it by x2 minus x1. And so all this formula memorization is a formal way of what we did rather intuitively. If we're going to figure out the rate of change, we had to figure out how much life expectancy changed. To figure out change, we did subtraction. For what time frame? And so to figure out how the time changed, we also did subtraction. So this allows me to write my model. Y equals mx plus b. And instead of m, I'm going to put in the rate of change or slope that I found of 0.19 years. And then I have to put my starting, and we started in the year 2000 with a life expectancy of 74.3 years. In this equation, my x stands for the years since 2000. And my y stands for life expectancy. That is what I'm calculating. So we actually have a second question that we're supposed to answer here, and that is to estimate the life expectancy of males born in 2019. So from the year 2000 to 2019 would be, that time frame is 19 years. So looking at my model, we said x represents the years since 2000, so I'll plug in the 19 for the x. So 0.19 times 19, and then plus 74.3. So I put that on my calculator, and I get y is equal to 77.91. And so that number is the life expectancy of a male that is born in the year 2019. Now, I also gave you information on this slide for females, and I would encourage you on your own to work through the same process of finding a linear model, finding slope for that model, and then using your model to predict the life expectancy for females that were born in the year 2019.